So we'll continue our lesson in chapter 13, and we are in section 1 about the scientific revolution. And specifically today, we will learn about the discoveries and inventions, and that is lesson 1.2. Go ahead, have your textbooks ready, or you can go online through our LODA USD website to Clever, and from Clever Cengage Learning, log in with your student account and password. And from the left side, it's Unit 5, Chapter 13, Age of Science and Exploration. And we are doing Section 1, the Scientific Revolution. The essential question for this chapter is, how did new ideas affect Europeans' views of the world? And the objective of this lesson is to identify how technology and the focus on direct observation led to important scientific discoveries from 1500s through 1600s. Prior to 1500s, Europeans believed that the Earth was the center of the universe. In lesson 1.2, it will discuss how improved technology and direct observation led to a change in that of thinking, as well as other important scientific discoveries in the 1500s and 1600s. In this lesson, we'll learn about the structure of the universe, biology, and chemistry. In lesson 1, we learned that for centuries or hundreds of years, many people, because of the scientists like Aristotle and Ptolemy, they believe that the center of the universe is the Earth, or it is known as the Geocentric Model or Geocentric theory. In time, scientists started to doubt this theory. So in the early 1500s, a Polish scientist by the name Nicholas Copernicus was studying the location of the stars to create a more accurate calendar. He noticed that his mathematical calculations worked better if he assumed that Earth revolved around the Sun. In his theory, he proposed that the Sun was the center of the universe. Later, it became known as the heliocentric theory. So Copernicus published this theory in 1543, the year he died. His theory challenged the long-held view of Earth as the center of the universe. So it's heliocentric versus geocentric theory. The research of other scientists supported the heliocentric theory. The German scientist Johannes Kepler concluded that Copernicus' basic ideas were correct. Kepler added that the planets had elliptical or oval orbits rather than perfect circular ones. There is another scientist that is worth mentioning that is not included in your textbook by the name Tycho Brahe. Let's learn more about his life as presented by Ted Ed.
How do you imagine the life of a scientist? Boring and monotonous, spending endless hours in the lab with no social interaction? Maybe for some, but not Tycho Brahe. The 16th century scholar who accurately predicted planetary motion and cataloged hundreds of stars before the telescope had been invented also had a cosmic-sized personal life. Tycho Brahe was born in 1546 to Danish nobles, but at age 2 was kidnapped to be raised by his uncle instead. His parents didn't seem to mind. Tycho was supposed to have a career in law, but after witnessing a solar eclipse at 13, he began spending more time with mathematics and science professors, who taught him the art of celestial observation. By the time Tycho's uncle sent him off to Germany a few years later, he had lost interest in his law studies, instead reading astronomy books, improving his instruments, and taking careful notes of the night skies. It wasn't long before his own measurements were more accurate than those in his books. While in Germany, Tycho got into a bit of an argument with another student at a party over a mathematical formula, resulting in a sword duel and Tycho losing a good-sized chunk of his nose. After that, he was said to have worn a realistic prosthetic of gold and silver that he would glue onto his face. Fortunately, Tycho didn't need his nose to continue his astronomical work. He kept studying the night sky and creating all sorts of instruments, including a building-sized quadrant for measuring the angles of stars. After months of careful observation, Tycho discovered a new star in the constellation Cassiopeia. The publication of this discovery granted him rock star status and offers of scientific positions all over Europe. Wanting to keep him at home, the King of Denmark offered to give Tycho his own personal island with a state-of-the-art observatory. Called Uraniborg and costing about 1% of Denmark's entire budget, this observatory was more of a castle, containing formal gardens, rooms for family, staff, and visiting royalty, and an underground section just for all the giant instruments. Tycho also built a paper mill and printing press for publishing his papers, and a lab for studying alchemy. And since no castle would be complete without entertainment, Tycho employed a clairvoyant dwarf named Jep as court jester. Tycho lived on his island, studying and partying for about 20 years. But after falling out with the new Danish king, he took up an invitation from the Holy Roman Emperor to become the official imperial astronomer in Prague. There he met another famous astronomer, Johannes Kepler, who became his assistant. While Kepler's work interested him, Tycho was protective of his data, and the two often got into heated arguments. In 1601, Tycho attended a formal banquet where he drank quite a lot, but was too polite to leave the table to relieve himself, deciding to tough it out instead. This proved to be a bad idea, as he quickly developed a bladder infection and died a few days later. But over 400 years after his death, Tycho still had a few surprises up his sleeve. When his body was exhumed and studied in 2010, the legendary gold and silver nose was nowhere to be found, with chemical traces suggesting that he wore a more casual brass nose instead. Tycho's mustache hair was also found to contain unusually high levels of toxic mercury. Was it from a medicine used to treat his bladder infection? A residue from his alchemy experiments? Or did his quarrelsome co-worker Johannes Kepler poison him to acquire his data? We may never know. But the next time you think scientists lead boring lives, dig a little deeper. A fascinating story may be just beyond the tip of your nose.
Another influential scientist, an Italian by the name Galileo Galilei. He made observations that further supported Copernicus' theory. So in 1633, the Catholic Church condemned Galileo's discovery and put him on trial. The church required Galileo to deny support for Copernicus' theory and kept Galileo under house arrest for the rest of his life. So over time, however, the heliocentric theory gained acceptance. The English scientist Isaac Newton further expanded scientific understanding of the universe in the 1600s. Newton proposed that the universe gravitation, which holds that all objects in the universe attract one another. With this law and his three laws of motion, Newton created a complete mechanical explanation of motion in the universe. The Royal Society of London, an organization dedicated to advancing and sharing scientific knowledge, helped spread Newton's ideas. His work would provide the foundation of modern physics that led to the scientific advances ranging from steam engines to space rockets. Now let's talk about biology and chemistry. So the invention of the microscope around 1590 allowed biologists to explore a new microscopic world and to observe things that had previously been invisible to them. Hooke was the first scientist to describe cells. Robert Hooke used his microscope to produce detailed drawings of tiny creatures such as fleas. In 1665, he coined the word cell to name the microscopic structures he observed in thin slices of cork. Hooke worked closely with an Irish scientist, Robert Boyle. Together, they discovered that air is made up of gases and determined how changes in the volume of a gas affect the gas pressure. They formed Boyle's law to describe this relationship. So Boyle's work with gases led him to propose that all matter is made up of smaller particles that join together in different ways. Boyle's theory challenged the idea of Aristotle, who stated that the physical world consists of the four elements: earth, fire, air, and water. The experimental work and writings of Hooke and Boyle greatly advanced the fields of biology and chemistry. Here are the models of Galileo's pendulum clock, Newton's color wheel, which he used in an experiment with light and invented the first color wheel. And the third one on the far right is a model of Robert Hooke's microscope. Okay, now let's go to the review and assess questions. For number 1, reading check. How did technology and direct observation help advance science in 1500s to 1600s? And number 2, make inferences. Why did the Catholic Church condemn Galileo's idea? And number 3, draw conclusions. How did Robert Hooke advance the field of biology? Now go to our Google Classroom and open the Chapter 13, Section 1, Review and Assess the Scientific Revolution. And go ahead, find the slide where Lesson 1.2 is located. Of course, fill up the basic information. We have the last name, first name, class period, and date. And the key vocab, heliocentric theory. Don't forget the title and, of course, the correct answers to the questions. And if you are aiming for the full credit, use your own word in complete sentences. That's Lesson 1.2 of Chapter 13, Discoveries and Inventions, pages 358 to 359.